Okay, welcome to this section. I'm Cristina Barbero from R2M Solution Italy, and I will chair this section. So I'm very pleased to welcome Amal Alrish.
Yes.
Is going to present a human-centered Internet of Things platform for sustainable digital mine of the future.
Good.
So
thank you, Cristina.
Yeah, if you want to sit here so they can see you,
Yes.
that would be great.
put myself here. Okay. Sit here. Okay.
So hi.
Yeah.
Okay, thank you, Cristina, for introducing me. I'm Amal Alrish from Road Technology. So we are presenting a Digit project. As Cristina said, it's a human-centered Internet of Things platform for sustainable digital mine of the future. Basically, our company is responsible for the cybersecurity layer, and we come here as a presenter and task leader for the dissemination and communication task. So it's coordinated by Maria Garcia Gamburbi from Itanova, and technical manager is David from Zodero. So together, we are Road Technology, together with 15 more partners. We are aiming to address the mining industry needs, and in order to achieve the sustainable use of resources while putting in and maintaining the environment and people at the front forth of our priorities. So these are all the organizations, our team, and we are from 9 countries all over Europe. So the concept, our concept is general and could be applicable to any kind or any sector. But for our case, we apply it in the mining industry. So we want to gather data, and then we want to add some value to analyze these data to see what is interesting for us, and then the output will be demonstrated on the interactive decision support system via smart dashboard. So starting from the data, here we're not talking about a lot of data, big data. We're talking about coherent data. So it's very important to investigate and know exactly what are the challenges and issues that these mines are facing every day. So saying that, we are gathering data at several levels. The first level is the people, so workers who are involved in the mining operations, and we want to monitor some data from the assets, so machines and vehicles that are involved in the activities of the mines. And also we will measure some of the environment, some important environment parameters regarding the humidity, gases. So the safety, basically the safety of these workers is an issue, as a very essential point for us. And also not to forget also the data for the ground. So structural and seismic stability of the slopes of the mines are very important issues. And finally, we will have this marketing data, so demand and commodity prices that are going to be integrated in our platform. Our platform, simply, it's a bunch of software, so put together and integrated together. So to say, shortly speaking, we will have digital twins at several levels. The first for digital twins for operation and maintenance, and digital twins for that soil level, so to study the geotechnical risks, and digital twin for the fluid dynamics, so to create and to model the health and environment risk maps. Of course, we will analyze these data to know and to get some added value. And we will have also a smart scheduling tool to optimize the mining operations. And at the end, we would have the predictive maintenance agent and predictive operation agents, which basically oriented to add some value to this data, process them, analyze them, and then get what are interested in, pass it to the next stage in our platform. And then at the end, this output would be demonstrated on our interactive decision support system via smart dashboard, which might contain the information about the parameters of operation, information about environment, health and safety monitoring parameters, and it's gonna have some alerts if some abnormal events happen. So roughly speaking, this is the main idea of our system. And in order to have all of this put together, we need to aggregate all of these technologies, communications, and techniques by having an aggregator. And then at the top of that, we need the cybersecurity layer, of course, because when we're treating with some data that could be confidential, so we don't need anyone to alert them. And then at the end, from the interactive decision support system, the end user or this DSS will assess the end user to manage the operation and to adjust it according to their needs. And also we will develop a blockchain, and we will implement distributed ledger technologies in order to open some of these data to the community. And by applying also a blockchain, people, our community will be, or mining community will be able to trust them. So with an eye towards the validation of our platform, we have selected 5 use cases, 5 pilots all over Europe. And given the complexity of the mining operations, which have different types and scales of processes, techniques, particularities, so these use cases have posed several challenges to the consortium regarding different environments, different parameters, life cycle stages. The first one is Marini Marmi in Italy. It's in Bergamo. It's an underground quarry for exclusive stones, which are famous there for Cipo de Grey on the right, so here, and Novolato de Grey, and it's used in the building. So saying that it's an underground quarry, so we can understand that there is underground, so workers are working with no connectivity. So safety is an issue, air quality, noise levels, even the unplanned downtime. We don't know, for example, if something happened to one asset underground, we don't know which part or like how much time it takes to repair this part. So if it is unplanned, so it's a big problem. And also having waste, a lot of waste down there, it's a big problem. And here, Digit is interfering to address these needs by predictive operation. So predictive operation will lead to waste reduction and reduction or reducing also the unplanned downtime. Predictive maintenance agent that I have mentioned before will lead to significant maintenance cost reduction. If we are predicting the maintenance time, for example, we will reduce the cost, and we will reduce the unplanned downtime, of course, and which will lead to the overall improvement of the the system or of the mine's operations. By monitoring the environmental health and safety parameters using a smart garment to measure all of these parameters, which does the cross-validation of these parameters of the parameters that, or of these parameters that could be biometrics parameters or even environmental parameters, which lead to enhancing the safety, and also not to forget the digital twins for fluid dynamics in order to create the models. The second one it's in Spain, La Parella. It's an open pit for tungsten mine. Well, this mine has been reopened, let's say, in 2018. So the lack of maintenance would add uncertainties of the behavioral, or the initial behavioral of the slope. So there is a lack of maintenance is an issue, and overall slope angle also is another issue, because when we have a lower angle, it's safer, but at the same time it will lead the occupation of large place, large landscape, and also it will lead to more waste. So Digit is addressing these needs by the digital twin geotechnical component, and by installing some of the sensors on the dam walls and rock faces. We will monitor the main parameters of the slope behavior, and we will provide the framework for the decision making according to the requirements, the requirements of the Parella. Now titanium, it's in Norway. It's an open pit too for illuminite material. It has several challenges regarding the water discharge monitoring, the slope stability. Being an open pit, of course, as we said in the La Parella, is an issue. The safety of the workers there is another challenge that we need to deal with. Also, predictive maintenance of the equipment and vehicles, and the overall scheduling of the activities in the mines. And Digit addresses these needs by the prediction of the maintenance, by the geotechnical digital twin, monitoring the environment parameters, and smart scheduling component. Well, CodeDEMO, being an underground for silver, it has more or less, let's say, for the same challenges as Marini Marmi. So it suffers from hazardous conditions, changing rock conditions, also unhealthy gases, air quality, etc. And more or less, we are aiming to use the same components in order to tackle them, but it's always not that easy, because each mine has its own features, so and its own environment and activities. So we need to go and investigate each of the mines. Hannukainen in Finland, it's an open pit for iron concentrate, copper, and gold concentrate. Basically, it's suffering from the lack of digitalization for the environment, operation, and environment health and safety. And it will address this using, as we said, the monitoring for these parameters, and also sustainability compliance labeling will be envisioned in this use case. Now, the current state and outlook, our first milestone that we have achieved was the harmonization between the expected improvement and the expectation from the end users and the requirements. And having analysis regarding several levels, regarding the data, the assets, geotechnical data, and so on. Well, next milestone that are going to be done very soon, or going to be completed, let's say very soon. It's the first cycle of the data collection. So the IoT edge, the sensors, the geotechnical and sustainable monitoring system will be completed, and to transfer the data to the next level, to the next stage. So to the digital twin in one work package, and to the predictive operation in another work package. And also the smart wearable will be ready soon, and its prototype also in order if we want like to change something, refine something, so we can do it easily, to have a prototype for that. And that's all from my side. I would like to mention that if you have any specific questions, technical ones, so you can contact here info@digit-h2020.eu, or basically you can contact the coordinator or the technical manager. Thank you for listening.
So thank you very much, Amal. Now we are going to present Lihnida. Hope I spell correctly your name. Lihnida Stojanovska-Georgievska of the University of Ss Cyril. And
yes, exactly.
Okay, Lihnida. Okay, and so you're going to present energy skills as a driver to sustainable construction, as current status, needs, and proposed actions.
Yes, that's right. Thank you.
Thank you. Go.
Let me share the screen. I hope you can see the presentation going.
Yeah.
Is it okay?
Yes.
Okay.
Yes, we can see it. Thank you.
Okay, thank you. Thank you for the introduction. My name is Lihnida Stojanovska-Georgievska. I came from the University St. Cyril and Methodius from North Macedonia, and I teach physics at the Faculty of Electrical Engineering and Information Technologies. I'm a part of ongoing project, SEEtheSkills, which is dealing with skills, as we say, energy skills that are used in construction to enable sustainable construction. So my today's talk will be to share some our experience and our findings, how are energy skills supporting sustainable construction. The talk will be target to show or to share our approach within the project, and to share also the most recent findings that result from the state-of-the-art research of the best practices in the field of energy skills on EU level, which is a result of our project, as I said, published recently and related to my today's talk. As we all know, sustainable construction is our common goal, nationally and also globally. Sustainable construction supports a series of advantages, benefits, but also faces some challenges. When we speak about sustainable construction, we assume that we are speaking about energy efficiency, sustainable use of resources, waste reduction, and so on. But in order to achieve all these goals, we need to implement certain methods, practices, and to select and to define most appropriate approaches to reach the goals. And beneath all of them, and as crucial prerequisite in order to reach sustainable construction are the energy skills. We need competent workforce, skilled and trained workers, qualified professionals. As stated in the title of the speech, our project is dealing with supporting development of energy skills. What is the project SEEtheSkills about? It is based on, we like to say, novel triple V approach, because we are dealing with the visibility of skills, then their validation in order to bring the value of the skills on the higher level. So this triple V approach is related to the visibility, validation, and value of skills. These are also the three main objectives or goals of our project. We are planning to achieve all these goals by creating the integrated database of energy skills, which will be integrated a place or area where three different databases will be interconnected and merged in order to support further matching, leveling, and mutual recognition of skills. We are speaking about a separate database of training schemes, which will list and link all the available training schemes, which will lead toward sustainable energy skills. Then the second database is related with the skilled and certified professionals. And then the third database will encompass materials and construction products along with their energy efficient properties. Beneath all the three databases are knowledge, skills, and competences in the form of the basic unit of learning outcomes. In order to be this unit of learning outcomes, or the basic elements that are encompassing the training schemes, the basic knowledge that skilled professionals from certain occupation should obtain, or the knowledge and skills that professionals in order to implement and to incorporate, to install building materials and products need to know are behind all these three databases. After creation of the integrated database or repository of energy skills, we will enable, as I said, a matching, leveling, and mutual recognition of skills, and it is supposed to result with higher value of the skills. Here, the target of this talk will be to share our findings and results from the research that was done in the first phase of the project, in order to find out what is the status quo of the energy skills on EU level, mainly in 5 EU countries that are partners of the project. This is the loop of the methodology of the research and its methodology. The research encompassed of desk research, then interviews, and one of the main part of this research is a pilot survey, when we surveyed professionals, but also companies, company owners, and managers regarding some questions related to energy skills. The key areas of the research were focused on some crucial questions, like the list of the skills that are already listed in the roadmaps and in the list of occupations, then the training schemes, how to reach these skills, the lists, existing lists of trained professionals and their number. We search whether there is a list or some database of companies that are employing skilled and certified professionals. Also, the status of validation of prior or informal learning was studied within this survey. And most of all, and most important, is the level of awareness of energy skills, not only among building professionals, but even more important, among the occupants and the end users of the buildings, owners of the apartments, and owners of the construction objects. So further, I will share some of our results that are obtained during this study. The study resulted with finding more than 500 sources of information or data sources related to energy skills. They were arranged and structured under Zodero platform, which has identified main challenges related mainly to the transition of energy skills from national to interregional level, but also has provided some ideas for the opportunities for solving national problems and obstacles for sharing maybe certificates or recognizing certificates and training schemes between countries and between different training providers. This is brief screenshot of this Zodero database and what it includes. Our 5 countries that I mentioned as partner countries in the project are Spain, our country, North Macedonia, the Netherlands, Slovenia, and Slovakia. So it is very comprehensive database, including most relevant data sources related to energy skills. When we are speaking about energy skills and the questions that were answered or for which we have found some answers during our study and our research are numbered here. They are related to the awareness, level of demand of energy skills, then legal requirements for specific trainings or available and prioritized training schemes. But most important is the definition of energy skills. And this was also the first question that was initiated by our consortium also. When we started to speak about energy skills, we started to discuss what is understand and what should be understood under this topic, energy skills. What should we list under this title? Our research has found that there are many different titles or quotes about energy skills. Here we speak about energy skills in construction. And after identifying this long list of skills and occupations related to sustainable construction and energy skills in construction, we have classified or structured all these titles of the skills or definitions of the skills in 5 different categories. The first category related to the building construction or builders, which are the main workers that work on the constructing of the objects, like facade workers, bricklayers, concrete workers, and so on. Then the second group are the building services or installers of certain installations, like electrical installation, HVAC installation, control system, and so on. The third group would be energy sources and installer for renewable energy sources, also professionals for energy efficiency. The fourth group are the managers or the leaders of the workers during construction, the foremen. And we have the fifth group consisted of some skills that are not that cannot be included in none of the above, and they are related to the cross-craft workers. But as we find later on, they are maybe most prioritized nowadays as a profession. Regarding the requirements for training and the existing training schemes, the already available and already enabled as a wide database of training schemes in sustainable construction is a BAS Advisor app, developed in the previous project from this call, and it is already spread across several, maybe more than 10 countries across Europe. So we identified this database, Bus Advisor App, as the main database of training schemes, which provide also the links to the available training schemes. Other questions were answered during our pilot survey on energy skills, which was run during March and April this year. It tackled two groups. The first group of respondents, the first group were construction foremen, and the second group were construction companies, their owners and managers. The questions were similar in both groups, but with some peculiarities which are more adequate for these two groups. And both lead to some conclusions. Both surveys or survey results lead to some conclusions that are summarized here. One general conclusion is that there is a lack of registers or databases, lists of skilled professionals. So this confirms the need of visibility of certified professionals. Then less than 25% or percentage or 1/4 of the respondents have answered that their skills are listed somewhere. And when we ask them where are their skills listed or their certificates announced, they are mainly on some websites of third parties, not on their company websites, and maybe on personal websites. Only 1/3 of the respondents have formal documents or certificates of their skills. So they assume that they have or possess skills that can be used in their further professional development or employment to enable their employment or higher prices, etc. But they don't have formal documents that validate their skills. So the process of validation of skills is also necessary. And a share of 82% of respondents have declared that they have achieved their skills through the trainings organized by professional organizations and including providers of construction products, which usually include some kind of training on how to install those products. One crucial conclusion is there is a need to increase the awareness of the value of skills. This is the conclusion from surveying the results or responses from the company owners when they are asked if they lack professionals with energy efficient and digital skills, what would they do? The answers were that only 33% or 1/3 will reskill their already employed workers. Only 11% will redeploy existing workforce, including some reskilling of this existing workforce. But more than 50% or half of them will hire external experts. So this is an alarm for action required in order to increase the awareness, mainly of the companies and company owners, for a long-term vision of upskilling and reskilling of their employed professionals and also workers. Identified training priorities are toward some of the most prioritized trainings. And here the findings both from the survey where respondents were the companies and survey where the respondent were the foremen are presented. The companies have identified BIM skills and digital skills as most important. Company owners, while the individual construction professionals, mainly technicians and foremen, have answered that they don't have such a polarized opinion, but they answered that installation of HVAC systems and also systems for renewable energy sources are important. Those trainings are required, and also cross-craft training as one of the most advanced and most necessary nowadays when interdisciplinarity is on the table. So after we have obtained these results, we are proceeding with the activities in our project related to the second and the third objective of the project, the validation of the skills, which should result with the increased value of skills. Within the project, two different pathways to reach validation of skills will be enabled. The first one through the trainings. We will put in place e-learning platform with several webinars or micro-learning trainings that will be offered beside the other ones that are already included in the Bus Advisor app, but also we will provide possibility to validate the skills of professionals that they already have through their previous learning, through their on-site jobs, through their experience, etc. So the process of recognition of prior learning developed in the form of iRPL tool will be put in place in order to validate the skills of the professionals. And as the last stage of the project, it will forthcome as an activity in the next period of the project. We will go toward increasing the value and promoting the value of skills. So after we find and define the most important skills and occupations that are needed, we will go through the validation of skills, and then in order to reach the final goal, promotion, showing the value and promotion of the value of skills. How we will confirm the value of skills? The idea is to use the digital skills in the form of BIM skills to perform some number of case studies, where these case studies will show the value of employing skilled professionals in order to bridge the performance gap, energy performance gaps in the buildings. We assume that this approach will result with showing the value of skilled professionals and their skills. So this slide also confirms that the thing that I said before. We will use energy skills in order to show their value by using BIM skills, which is also vice versa relation, which should also result with confirming the value of digital skills like BIM skills. Another tool that will be developed within the project in order to act toward increasing the value of energy skills is to tackle the homeowners to recognize the value of energy skills through self-evaluation of their apartments. Post-occupancy evaluation tool is already implemented in one of our previous projects, but now the aim is to spread it and also to modify it to be more user-friendly for the home owners and the occupants, in order to make self-evaluation of their apartments in terms of energy efficiency of the apartments, and they will get some kind of results like this regarding the quality of construction, the quality of appliances and energy efficiency measures that are implemented, and also, most important, some recommendation will result with the links to the database of available skilled professionals that could implement those measures in order to increase the energy efficiency of the apartments of the owners. So the benefits will be multiple for a number of different groups, different end groups, like the occupants, as I mentioned before, but also design teams, investors and construction companies, and local and national authorities. And this is something that should follow in the next period of our project. I will go toward the conclusions of my speech with the same slide with which I started. In order to reach sustainable construction, sustainable offer of energy skills is more than important, and it is all the prerequisite for reaching our sustainable future. One of our partners in the project likes to use this quote, and that's why I put it on the last slide. Let's change the building workforce in order to change the sector. Thank you for your attention. I hope I stopped sharing my slide. Thank you.
Highly detailed, and we really appreciate. And now we are going to present another paper from University of Bradford. Gurkan Yildirim is going to present. No,
He's not there. Oh, no, Gurkan is here.
Yes, Gurkan.
Okay, you came. Great.
Okay.
Hi, can you hear me?
You're going to present upcycling waste originated from construction and demolition practices to manufacture geopolymeric construction materials.
Hi,
So,
can you
we
hear me
can-
now?
Yeah,
Yes.
perfectly.
Okay, and you can see the screen, yeah?
Yeah.
Yes.
That's
Thank you.
fine.
Go.
So I will just start because I can't see you. I think this is how it should be. Hello, everybody. My name is Gurkan Yildirim. I am from Turkey, currently working at the University of Bradford in the UK. These are the preliminary results or midterm results of a project funded by the European Union under the title of CodeDEMO, where we are trying to transform construction and demolition waste into concretes that can be demountable like Lego pieces into structural elements which can be demounted in the future. I am a Ss Cyril individual fellow, but I'm also working as an associate professor in Hacettepe University in Ankara. So today's talk will be, as I said, on the midterm results of this project. So as a quick introduction, as I mentioned, this project is about upcycling of construction and demolition waste. What we do is to transform already widely available wastes into new cements and concrete mixtures, then to use these green concrete mixtures in demountable structural elements. So where does the construction and demolition waste come from? It's mainly due to our increasing population, immigration, unplanned urbanization, and catastrophic events such as flooding or earthquakes, which lead construction sector to grow. But this also brings about the problem of demolishment and rebuilding of structures, which also requires a lot of raw materials and new concrete mixtures and cement to be produced, which leaves us with a high amount of greenhouse gas emissions. In the end, we came up with the idea of transforming this construction and demolition waste, which is the largest waste stream in the EU currently. And it's a huge problem, especially in Turkey, where I am coming from, because Turkey tries to transform its infrastructure in the upcoming 20 years, which will leave us with a lot of construction and demolition waste. So as a result of urban population and transformation, as I mentioned, and continuous development of industries around the world and growing economies of countries, construction and demolition waste industry has become huge. You can see from different plots here, different graphics here, that the waste generation per capita in different countries and the level of upcycling or recycling construction and demolition waste is considerably different. For example, in Turkey, we expect much higher levels of construction and demolition waste per capita. And when you take a look at more advanced countries, let's say Belgium in this regard is really good. They can transform the construction and demolition waste up to 80%, 85% in that range. So, but what they do is quite straightforward. They just crush these materials and use it as raw base or sub-base materials, which is downcycling. So what we are proposing is to use these materials in an upcycling way and to make the most out of these materials. Because when we stop building roads, what are we going to do with these construction and demolition waste? So we need to come up with more innovative and up-to-date solutions. There are, of course, multiple adverse effects of construction and demolition waste. One of them is that you need to stock these materials in open areas, and this will leave you with the need of having large, clean landfills. And this will, of course, release some hazardous, this will lead to hazardous pollution. And of course, you're going to waste your natural resources. And to build a new structure or building, let's say, you will need clean raw and construction materials, let's say cement, aggregates, or concretes in the end, which will also increase the global warming rate. So our aim in the CodeDEMO project is, as I mentioned, is to produce or develop completely green concretes out of construction and demolition waste. So what we do here, we get rid of Portland cement, which is the main binder or glue in traditional concrete. We get rid of Portland cement entirely by using alkali activated materials made out of CDW materials, such as tiles, bricks, and waste concrete and waste glass powders in mixed and single forms. And then we incorporate waste concrete aggregates into the designs of these geopolymeric binders or alkali activated binders. So in the end, we obtain a green concrete material. This is what we aim currently, because we couldn't get to the stage where we get the concrete mixtures, but we are currently developing it. And then we look at different parameters, such as what happens when we use CDW waste-based materials individually and in combination, because construction and demolition waste includes wide variety of materials such as tiles, bricks, waste concrete, waste glass. So how about if we use them in combination, or when we use it individually, which one would be better? So this is one of the questions. And to use these materials in geopolymeric materials, geopolymeric binders, which is free of ordinary Portland cement, you need alkaline activators such as sodium hydroxide and sodium silicate or calcium hydroxide. So another question is to determine what will be the optimum rate of alkali material usage. Another issue is how you're going to cure these materials, because as in normal concrete, you need to cure your material, but this is a bit different in the case of geopolymeric materials. And another issue is we need to use aggregates inside a certain binder to obtain mortar or concrete. What will be the size, maximum aggregate size, and the volume or utilization rate of recycled concrete aggregates? And in the end, what we need to achieve reasonable compressive strength and material with microstructural and durability characteristics similar or better than the traditional concrete. By doing this, we get rid of the aggregate quarrying, we get rid of the permanent marks on the planet, which is caused by the production of Portland cement, and we also reduce the greenhouse gas emissions significantly. So what we proposed here is explained in the experimental program slide. You will see that in a normal conventional structure, you would have glass, you will have roof tiles, hollow bricks, different types of red clay bricks and concrete. And when you demolish this structure, you obtain these materials all together. But the new idea is a new approach to demolition of structures is more centered on selective demolition, where you obtain these materials separately, and so that you can choose in different proportions in some of these materials depending on your need. So as a result of this selective demolition procedure, we collected hollow brick, red clay brick, and roof tile, and glass and concrete wastes. We crushed and grinded them in the laboratory conditions. And of course, you need to have like certain fineness to make these materials reactable with the alkaline activators you see on the right side, such as sodium hydroxide, sodium silicate, and calcium hydroxide. Of course, then we add recycled concrete aggregates after crushing and sieving into these geopolymer binders to obtain the mortars and concretes in the final stage. This is the midterm results. This is the compressive strength results of geopolymers, which are based on construction and demolition wastes. But this is our first step of our work. So we focused on single utilization of these source materials: roof tile, red clay brick, hollow brick, glass, and concrete. And we only use sodium hydroxide as the alkaline activator. And in order to get a reasonable strength level, compressive strength level, we needed to cure these materials in oven at 105, 115, and 125 degrees, because the lower degrees of temperatures didn't give us like good results in terms of compressive strength. So we increased the level of heating. But just keep in mind that this is only with sodium hydroxide and only with single materials. And what we get, as you see here on the left side, is a microstructure which was very dense. And this was the case for clay-based source materials such as tiles and bricks. But what we saw, especially in the case of glass, was a bit non-uniform microstructure, and with glass particles not dissolved very properly, which left us with compressive strength level a bit lower. The same case was observed in the case of concrete. The same situation was valid for concrete as well, because concrete has some concrete waste has some unhydrated and hydrated cement and concrete particles on it. The strength results when we singly activated concrete waste was a bit low. So we came up with the idea of mixing these materials in order to get a better strength results, and in order to diversify what we're using as source materials. Because when you demolish a certain structure, what you get is the combination of these materials all together. So it's not logical to use roof tile alone or clayey materials alone, but to leave glass and concrete separately. So we combine these materials to obtain geopolymeric binders. You would see when we use in the range of, let's say, 60 to 80% of clayey materials, such as roof tile, bricks, and other types of ceramics. And when we keep the utilization rate of concrete and glass in the range of 30 to 40% of the total amount of binders, and when we use the same alkaline activator, sodium hydroxide, and what we got was up to 56 or 57 megapascal compressive strength in 2 days of heat curing. Heat curing is energy intensive, as you might imagine. So what we wanted in the following step was to get rid of heat curing, and we tried different alkaline activators to do that. We were using sodium hydroxide at the beginning, then we combined sodium hydroxide with different alkaline activators such as sodium silicate and calcium hydroxide in different proportions, and then we incorporated the CDW-based precursors or source materials and geopolymers with fine and coarse recycled aggregates coming from waste concrete. So in the end, what we are left with is a concrete material made out of completely construction and demolition waste. This is the following step. This is where we are at the moment, and we are currently working on developing concrete mixtures with coarser aggregates. You can see when we combine sodium hydroxide with some amount of sodium silicate, SS means sodium silicate, we were able to get almost 25 megapascal of compressive strength under ambient curing. So we got rid of the heat curing, which was very energy intensive. And when we incorporated these microstructure, these proportions with only 20% of GGBS slag, ground granulated blast furnace slag, the strength levels increased even higher. And we were able to reach almost up to 35 NPa compressive strength. But the project, CodeDEMO project, proposed completely CDW based concrete. So although this strength level is higher in the case of slag usage, we are still trying to develop this 25 MPa strength level, which is fine, but we are still trying to increase the level of compressive strength by changing the mixture proportions and working on different proportions of alkaline activators. So we did some further tests. Another issue in the case of geopolymers or alkali activated materials is the drying shrinkage. This is also another issue in traditional concrete mixtures, but it becomes more pronounced in the case of geopolymers. So depending on the use of different types of alkaline activators, we were able to terminate, or not terminate, but limit the drying shrinkage strains significantly. Depending on the type and utilization rate of your alkaline activator, you could see that the microstrains forming as a result of drying is significantly different. So when we use sodium hydroxide with calcium hydroxide, there were no cracks in our drying shrinkage specimens. But when we used sodium hydroxide, sodium silicate, and calcium hydroxide combined, we were to see some surface microcracks, which is not desirable in terms of durability. But when we combine 100% CDW based mixtures with 20% of slag, we were able to, up to 20 to 30% reduce the level of microstrains as a result of drying. So this is also comparable to traditional cement mortars. Just we need to keep in mind that the level of utilization rate of aggregates here is important, because when you increase the amount of aggregates, you reduce the shrinkage in general. We only focused on utilizing one utilization rate of recycled concrete aggregates. So we didn't try increasing the amount of aggregates. When we increase the amount of aggregates, we expect the drying shrinkage strains to go down significantly. Another issue related to the geopolymers is the efflorescence formation, which is the leaching of alkali metals to the surface of the mixtures. And when these alkaline solutions are leached, they react with atmospheric carbon dioxide and leave the surface with the efflorescence products, which you can see as white traces, as you can see here. The white traces of efflorescence products are mostly related to the formation of sodium carbonate, which is also called as nitrite, and you can see on the right side of the slide. But we were also able to limit the efflorescence behavior, efflorescence formation, significantly by changing the type of alkaline activators we used. So depending on what we used, you would see we were able to eliminate efflorescence formation significantly. And although there were some efflorescence formation, this didn't cause any problems in the mechanical property results and the strength level of the developed mortars. Even when we use 100% CDW, we're still okay. These are the SEM pictures with some EDX analysis on the right side. You would see.
Gurkan, I just ask you to wrap up because we are
Yeah,
running late. I just give you,
okay.
yeah.
I will just skip this, and this is my last slide before last slide. So I'm gonna wrap it up. Sorry. So this is the sustainability analysis we did. You would see that we took a look at embodied energy and the CO2 emission analysis. What we were left with, what we saw in the end was that we were able to reduce the embodied energy, and the amount of carbon dioxide that will otherwise will be released to this atmosphere would be significantly reduced with the use of geopolymers based on construction and demolition waste. You would see this was mostly related to the utilization of sodium silicate, and now we are also working on developing sodium silicate out of waste glass, which would reduce the level of CO2 emissions significantly. So as a conclusion, we managed to show that it is possible to develop concrete mixtures, mortar mixtures with significantly lower CO2 emissions and energy requirement with complete deconstruction and demolition waste. And we were able to reach compressive strength levels and with suitable durability properties comparable to traditional Portland cement-based systems. So thank you very much for your attention. If you have any questions, I will be more than happy to answer.
Thank you very much, Gurkan. Thanks a lot. Because I just pressed you to finish, but we are running late, and
I'm
now
sorry.
I would like
I'm
to
sorry if I took long. I'm sorry.
Don't worry, you were very clear. So thank you. I want to introduce now from ITEC Licinio Alfaro, and he's going to present TCQIGMA environmental software. So quite curious about this paper and this acronyms. Thanks. Go.
I think it's Miltiadis, no? Yeah.
It's no, it's
No, Licinio Alfaro is not here, so it's Miltiadis.
Okay, so it's not present. Okay.
No.
I thought it was one of the present here. Okay, sorry, it's not present. So we go to.
It's frozen. It's completely frozen.
Miltiadis is present, but I thought it's.
No, yeah, Miltiadis is present. Hi, sorry.
Okay,
you were frozen.
sorry, I thought it was frozen. Okay. Okay, so Miltiadis, we go with you. Miltiadis from RINA Consulting, and you're going to present Metamaterials and the built environment, a review into their perspective for the enhancement of resiliency. So
exactly.
And we also hear you very well. Thank you. Go.
Okay, so hello to everyone. Let me share my screen first. One moment. Okay, you can see my screen. Okay. Can you see my screen? I can't hear you.
Yeah, we are muted, sorry. We can see your screen perfectly fine. We're just sorting out a bit of the audio here that went crazy, but we hear you, but not on the main.
Okay, okay. So I'm gonna start. Okay.
Yeah.
Okay. So before starting, I want to say that this presentation was supposed to be in the resilience section. So it might seem to some people in the audience that it is not so correlated with the sustainability construction session. But it's a nice opportunity to introduce you also to metamaterials, and I will try to align, let's say, the theme of the presentation with sustainability in the end of the presentation. So I want to present myself firstly. My name is Miltiadis Kontogeorgos. I am a PhD candidate in the National Technical University of Athens, while I am working simultaneously at RINA Consulting S.p.A, and Clemente Fuggini is a colleague of mine, and we work on the concept of metamaterials. So our presentation is about metamaterials, and I will give you a short and brief introduction about metamaterials. So, metamaterials is any material engineered to have a property that it is not found in natural occurring materials. Just like all of the construction materials that we are using for designing our structures. But the special characteristic is the periodicity in their structure. This means that we don't have the material like concrete as we have in our minds or wood, but we have different materials placed in parallel, and then we have a specific pattern. And in the figure that I am having right next to the text, you can see that a schematic representation of metamaterials, which is about one-dimensional. That means that we have periodically different layers of materials. We have the 2D, which is not so common, and we have also the 3D, which is right here. And this means that within a solid medium, we have spheres of different materials, also aligned in and set in a specific manner and with specific distances between them. This is a novel concept because we have observed that with this structure, we have special characteristics and special behavior in the dynamic field, namely in the frequency domain. So, literally, the band gaps, as I am saying here, are mitigation zones that refers to specific frequency domains, and that means that the waves, the transmitting waves through our medium for specific frequencies of the wavelengths, it is observed a mitigation or even a denial to the waves in transmitting our medium. This means that we can protect our structures because we are not letting the waves to transmit our medium. So the energy that the waves are carrying with them is not affecting finally our structure. In order to be more specific, this is the most special characteristic of metamaterials, which is the band gaps. And the band gaps, you can see that here is the zones that means that within these frequencies, the waves are being denied its transmission through our medium. And all, let's say, our goal is to finally calculate these band gaps in order to know, according to the hazard that we are dealing, what are the desirable frequencies that we want to stop and so far protect our structures. I will briefly present, just to take a taste, the two dominant theories for calculating these band gaps in order to have an idea how we can design a metamaterial. So the first theory is the periodic materials theory, and it is based on the resolution for equation of motion for its layers. That means that we are examining a wave transmission through periodic layered material, and we are using the four boundary conditions, including the Bloch-Floquet theorem, in order to produce these dispersion relationships. Here, K is the wave number, H is the thickness of the unit cell layers, and R, C, and T are the some parameters of our materials. The next theory is the mass-in-mass modeling, which may be more familiar to a broader audience of engineers, and it is based on the resolution for motion for the infinite lattice, because we are assuming that this is an infinite lattice in the beginning, and then we are reducing let's say our calculations to the finite lattice, because in final we have a finite lattice. An infinite is not achievable. So here the equations for calculating the band gap are far easier, but they have also some restrictions when we are trying this methodology for the 2 dimensions and the 3 dimensions. These were some brief introduction just to have a taste for how we design the metamaterials. And now I am entering into the basic aim of this presentation. Metamaterials and the built environment. Almost to every dynamic nature hazard, we can develop metamaterial concept. And this way, we can block the consequences of various phenomena from seismic hazard, noise pollution, blast hazards, and enhance the resiliency of systems, of buildings, of our structure, and finally, the resilience of our community. In this schematic, you can see plenty of meta concepts that I have categorized in the right column according to the hazard that we are dealing in every case. So for seismic hazards, we can have the meta plans. Some projects have dealt with calculating the mitigation effect towards seismic energy of forests, for example. We have the seismic cloaks, which are only for surface waves. We have, of course, the meta foundation that you can see also here, and the meta gravel, which is for the protection of underground gas transmission pipelines. Towards noise pollution, we can use also acoustic meta panels that you can see with the yellow here, or the meta rail. This means that we can create ballasts, if you know, a metamaterial based ballast for denying and absorbing the low frequency vibration caused by railways passing through or nearby cities or buildings. And also a more, let's say, closer to public safety and security hazard towards blast hazards, which can mean terrorist attack or during war zone time, for example, surface explosions or again terrorist attack, that we can use also meta panels like this one, but not for acoustic reasons, and metamaterial layouts that we can bond around the gas transmission pipelines. With this way, we can mitigate or even isolate our structures towards hazards, and that means, of course, that we can achieve an enhancement of the resilience capacity. To be more specific, I have included in my presentation some real cases connected to energy infrastructure. The concept of the periodic layered foundation has been tested experimentally. We can see it on the left column. And I'm not so sure if you can see, but the mitigation in the seismic induced displacements is obvious here with the red color. And on the right, there is a schematic of a real case implementation of a metamaterial concept. This is a meta foundation concept for the seismic protection of fuel storage tanks. This is the problem so far with the metamaterials because we are designing now. We need big dimensions for our metamaterials. It is not so easy at this stage of research to use metamaterial concepts for common buildings and structures. And for this reason, we have started from critical infrastructure and structures that demands bigger dimension in the foundations. Of course, along with the concepts for meta foundation, we have also meta foundations designed for nuclear plants. The solution here has been used for a nuclear plant, meta barriers and meta concepts for the protection of wind turbine blades. Of course, as I said before, all concepts are aiming to increase the resiliency capacity of our infrastructure. Finally, here are some potential meta concepts of today and future. We suggest the first four suggestions are including critical infrastructure. That means gas transmission pipelines or underwater transmission pipelines, offshore wind turbine and electricity plants, against various types of hazards like blast hazards, surface explosion, underwater explosion, or seismic hazards. We have named specifically some potential metamaterial concepts. For example, we can use the meta foundation concept, which has been implemented for fuel storage tanks in electricity plants, and this way increase the resilience capacity of electricity plants. And secondly, more closer to our community built environment, the seismic protection of the city's buildings through meta barriers covering the perimeter of a built area and environment, and of course the transportation network, both within our city, but also for critical transportation networks, especially including bridges. We can use meta asphalt and so far protect or help enhance the recovery of the transportation network after a war episode or a hybrid war episode, which is more and more common these days. And of course, the further development of meta concepts is continuing until today. Thank you very much for your attention, and I am open to answer to any of your questions.
Thank you very much, Miltiadis. And I don't know if there are some questions, if somebody wants to give some tips, and if not, I have one. So I go with my question. I'm very impressed. I'm very impressed about how sustainable constructions have improved. So I have a general question to all of you, as I'm an expert about energy efficiency, but I always thought that building sector is far from being perfect. What I saw today is that technology is ready. We have lots of new innovative ideas and concepts. Why is it so hard to implement? Why do we have to wait always for EU laws on regulation to push the companies. As I understood, sometimes if you implement as a company, you can save money, you can be more efficient, you can use in a more efficient way your resources, no matter what you're doing, construction, mining, whatever. So why is it so hard? It's still so hard.
If you are asking me, that I believe that you are asking me,
It's open to all the. It's open to all the.
yeah, I understand.
Really?
But I will take the lead. I will answer first. So from my experience, because we are working, I am working in a company which is dealing with numerous EU funding research project. The general strategy of the companies, of the medium and above companies, is exactly to develop novel concepts and then implement them in the today practice of the company. But the problem is having two sides. The first is to transfer the research knowledge into a real case, which is not so easy, because now, for example, on the metamaterials, we are dealing with metamaterials almost all the previous decade in the civil engineering practice, but the first real cases came up after 7 and 8 years, because it is something new, and it is needed to satisfy some conventional demands that we have for designing our buildings. This is the first concept that through and via our hard work we can surpass. But the second obstacle, which I believe is highest, it is harder to persuade people designing into a specific way to use the new concept that we are developing. Sorry for hearing.
Miltiadis, are you speaking from a church or from somewhere? I don't know where.
Yeah. I have a church near my house, so I am gonna mute for a while.
Okay. No. So I don't know if there's somebody from the other speakers while and Miltiadis is going to transfer to another room. I don't know, Lihnida, if you're still with us, if you want to add something.
Yes, I'm here. I agree with the comments of Miltiadis. Every new technology is very hard to put in real place, in the places where it should be implemented. And this especially refers to construction sector, which I think that is a common situation in all the countries. Construction sector is maybe the most traditional one. Is for the implementation of technology, but also for accepting new technologies, because it is consisted both of blue-collar workers and white-collar professionals, which we must say much easier accept the new technologies, digital skills, and new tools, but to transfer that to the workers, to blue-collar workers on site is very much, it's hard. From my point of view and our experience that I partly shared in the presentation, we even, by implementing this process of recognition of prior learning, which is new for construction companies, we succeeded to implement it in some big construction companies in our country in order to have their workers certified. But what was the result? The owners have collected all the certificates of the workers and don't distribute it to the workers in order to use them for their further let's say employability in other countries or other companies. So we finished the process, and the certificates stayed locked. I hope you hear me. So I will finish that construction sector is really the most traditional one.
Yes, we are still with you. Sorry, we just had some problems, in the technological problems. So go ahead, Lihnida.
Yes, I'm not sure until when did you hear me, or you didn't hear anything.
We don't have any kind of. Right. Can you
I
speak?
personally heard everything.
Okay, no, but
Also, can I add something?
Okay. Okay. We have a couple of minutes more. If you, go ahead.
Okay. Mrs. Sterling, your image has been freezed to me. I don't know if to Mrs. Stojanovska is the same, but I have seen you freezed in my screen, but it's okay.
Amen.
Yeah. Also, one extra thing that I wanted to add from the industry experience is that it demands also an extra cost for companies, because when you have a patent, when you have developed a new concept, in order to take license from national authorities, you have to test these to let's say national laboratories and take license. This means an extra cost that many companies may don't have the financial capacity to cover these costs. So if the country has this framework, because from what I know in Greece, it's far more difficult to make a patent for a new development like meta foundations. And I am not so sure that this is not that Greece's framework is the exception of the European countries. Only I believe that only few countries has a framework for approving solution outside of the conventional design. And if this happens, that means that we are finding this on very big projects and where we have no other solution. So I believe also that this is a problem of frameworks and policies, to find a more flexible framework to allow new developments to be implemented in projects of minor importance on common buildings and all this stuff. In the sustainable section, I am far more optimist, because we have set some goals that we want to achieve in the near future. So these will change, I believe, until 2030. It will change dramatically. I'm not so sure about the conventional design and the new concepts on the designing of bridges, for example. Thank you.
Thank you. I don't know if I think we have to close. I don't know if Gurkan, if you want to speak the last word, or
No, I agree with both Miltiadis and Lihnida.
Okay.
Thank you very much for coordinating everything.
Yeah, there's somebody from here. Okay, let's go.
I don't know if you can hear me.
I'm afraid to turn. Just come here. Yeah, that's better. Okay. That's the last contribution. Just one couple of minutes more.
Yes.
Go.
So our probably like our project is a bit different from like the project that I have seen in the presentations. It's about like mining industry, but I can also agree with the Lihnida. Yeah, when she said that about traditional places, because mining industry, like many mines in Europe, like it's traditional industry. So we might have some problems in the implementation. For example, just to have an example, in convincing, for example, the worker to change their way of working. So it was kind of like a proposed risk. It was a foreseen risk. So we were probably we can limit the amount of the data that we will give them to the least possible, or like we would just like have some workshops, like small workshops, can give them what is needed, what is really needed, and like apart from like other problems related to the environment and to the application of these let's say technical and theoretical technologies on the ground. Yeah, that's it. Thank you.
Thank you. Thank you very much. Thank you very much to all of you. It was really a pleasure to know a little piece of technology I wasn't aware. So thanks a lot, and thanks to all the presentations, and have a nice evening. Thank you a lot. Thank you.
Bye. Thank you.
Don't even know what I'm doing.